very poor energy volume relationship. And that means, for example, that you need a lot more space to store the fuel. Depends on the range you fly, how much payload it's going to cost you, but it's going to cost you at least 15% on short range routes and 40% on long range routes. And then to get it into the aircraft is also a problem, because if you want to have hydrogen and large energy weight relationship, you have to enormously compress it or to liquefy it almost to absolute zero. Well, those three aspects make hydrogen, in my opinion, not suitable for aviation.
Today, we're diving deep into the world of hydrogen aviation with a man who spent more time in cockpits than most birds flying. Bernard von Dijk has been keeping planes in the air since 1982, back when safety demonstrations still included smoking sections. He's now part of the Hydrogen Science Coalition, which sounds like a superhero team, but is actually a group of people telling us why hydrogen planes might not be the silver bullet everyone thinks they are. At a time when companies are promising us flying unicorns powered by rainbow hydrogen, Bernard's here with 40 years of experience saying, "Hold my Heineken." He's the rare combination of someone who can explain both why planes stay up and why some ideas should stay down. Bernard, welcome.
Thank you very much, Anders.
So, Bernard, what got you into aviation?
Well, I was an aviation enthusiast when I was a teenager. So I already knew that from my early days on, I want to do something in aviation. And after my high school, I went to the University of Applied Science in Haarlem to study aeronautical engineering, which was a really nice study. Thereafter, I went to KLM to be a ground school instructor and a flight operations engineer. And after 20 years of KLM, I went to the University of Applied Science because they were looking for a lecturer of airplane performance and stability and control of aircrafts and aerodynamics. So I made a career switch from KLM to the University of Applied Science in Amsterdam, and been teaching there since my retirement in 2022. And I was just about then contacted by David Seaborn and Paul Martin if I want to be part of their Hydrogen Science Coalition as an aviation expert, due to my article which I published on LinkedIn about hydrogen in aviation. And that is in short my story.
So we're going pretty granular today because I want our audience to understand all aspects of this. And from your physics background, what fundamentals make hydrogen such a tricky element to work within the aviation?
Well, the first thing you need to keep an airplane flying is that you have to have an energy carrier which has a large energy content per weight and energy content per volume. Well, hydrogen satisfies the first one, but it doesn't satisfy the last one. It has a very poor energy volume relationship. And that means, for example, that you need a lot more space to store the fuel. That's the first problem which you're up against. And the second problem that you're up against is that hydrogen itself is very explosive. It is a really dangerous substance. And the poor energy volume relationship makes it impossible, almost impossible, to store the hydrogen in the wings. So the hydrogen has to be stored in the fuselage, and that's going to cost you payload. And it depends on the range you fly, how much payload it's going to cost you, but it's going to cost you at least 15% on short range routes and 40% on long range routes. And then, of course, we have the second problem, and that is that hydrogen does not occur naturally, so you have to produce it.
Yeah.
The nice thing from jet fuel is it's made from crude oil, which is very cheap coming out of the ground, but hydrogen is not. We have to produce it, and that costs vast amounts of energy. So that is, I calculated it for the European flights. We need at least 89,000 wind turbines of 8.4 megawatts to produce the hydrogen if we want to replace only the European flights with hydrogen. So that is really an enormous amount of energy. And then to get it into the aircraft is also a problem, because if you want to have hydrogen and large energy weight relationship, you have to enormously compress it or to liquefy it almost to absolute zero to be able to use it. And that means that processes of compressing and liquefying the hydrogen is also enormous energy intensive. So
Yeah.
that means that before it is in the aircraft, you have so many conversion steps on the way that it will also be very expensive. It is a very expensive fuel. Well, those
Yeah.
three aspects make hydrogen, in my opinion, not suitable for aviation.
Here's what blows my mind. Is the lightest element but needs huge tank. How
Yeah.
do you design an aircraft around that?
Well, if we're going that way, if you want to use hydrogen in aviation, we need totally different aircraft designs. Because now you need so many hydrogen that is impossible to put it into the wing. The tanks will also be very large because you either have to have very strong tanks to resist the enormous pressure of 700 bar, which is for the audience almost 5,000 pounds per square inch. That is an immense high pressure. Or you have to have very well isolated tanks because of the cryogenic temperatures of hydrogen in its liquid state. And that means they don't fit into the wing, so they have to be in the passenger compartment. And that makes for conventional aircraft designs that you lose a lot of payload. So if you want to have enough hydrogen on board, you need fundamentally different aircraft designs. And those aircraft designs are flying wings, we call them, or blended wing bodies. That are the aircraft designs which may possibly hold enough hydrogen to fly the desired routes.
Talk to me about integration challenges. When you're putting hydrogen fuel cells into the aircraft systems, what's the biggest headache?
Well, the biggest headache is are the big tanks and all the parts that come with it. It is a very complicated technology.
Yeah.
Fuel cells are very heavy. They have a poor power weight relationship. So you also need batteries for to get enough power for takeoff, for instance. And so the storage is one of the problems, is really the main problem to get sufficient hydrogen in the aircraft to fly long routes. And that is actually the main problem in this case.
Although you did mention some of these, but let's go into these detail by detail. Now, how does hydrogen affect the basics like range, payload, takeoff? What changes?
Well, payload we already talked about. It's going to
Yeah.
cost you 15 to 20% payload of passengers. And the other thing is that hydrogen is not a simple technology. It is a really complicated technology. All the pumps, valves, and compressors, and all the things you have to have on board. That makes it from an operational standpoint, difficult to maintain. If you look to the difference between a battery, if you go to cars, to a fuel cell car and a battery operated car, there are battery operated cars are much more simpler. So this is a complicated technology. And we know that it is a complicated technology because Airbus has tried before. In the 90s, there was a consortium of universities and Airbus which tried to make a cryoplane. That was the
Mhm.
first hydrogen project of a plane. And in 2000, the management of Airbus said, well, we're not going to make this because the technology is way too complicated and it is much too expensive. So that is from an operational standpoint. And also the refueling of an aircraft will be much more complicated, especially when you use liquid hydrogen. Compressed hydrogen, that's doable, but liquid hydrogen is very difficult, complicated process.
Yeah. Cryogenic technology sounds like a sci-fi stuff. But what breakthroughs do we actually have or need to make this work?
Well, that is difficult because you're limited by the chemical and physical properties of hydrogen. And
Yeah.
that is not going to change. I always say hydrogen hasn't changed its properties since the beginning of the universe. And that is really the problem here. You can't get around these difficult systems because of the physical properties of hydrogen. And that
Mm.
is what we're up against. So, that is not going to change. You can make maybe, if you look at the price perspective, you can make the electricity a little bit cheaper. But also, if you look at the total price of a kilogram of liquid hydrogen, on the moment it is around $15 per kilogram. And where you can tweak, make it cheaper, are only the actual two things. That is, maybe the electrolyzer is going to get cheaper, or the electricity is going to cheaper. But all the rest in the steps in the process are pumps, valves, pipes, and all that kind of stuff, which we are making for hundreds of years already. Yeah, because some people say hydrogen is a new technology, which is totally not the case. We're
Yeah.
producing hydrogen with electrolyzers already since the beginning of the 1900s. So that is a mature technology. You're not going to make that cheaper. So that
Yeah.
means that there are only 2 points where you can tweak on the price, but the rest is stays the same. So I don't think from a price perspective it is not interesting. It will be too expensive.
And there's potentially embrittlement issue.
Yeah.
What happens to these materials when they're in the air? Does that happen?
Well, we know how to mitigate this. The hydrogen embrittlement is more a problem if you want to put hydrogen in, for instance, gas pipes.
Yeah.
Then those steels are not suitable for hydrogen transportation. But if you make an aeroplane flying on hydrogen and you know that you're going to use hydrogen, you can use special materials for this, and then it's not so much of a problem.
And what about hybrid systems? What potential do you see there?
Yeah, I see a lot of the potentially I see in hybrid systems is not hybrid hydrogen systems, but hybrid electrical systems.
Yeah.
And I think that will happen really soon. For instance, Ampere is really busy with it. That you make a kind of a hybrid aeroplane, which uses partly battery electric technology and old-fashioned jet fuel technology. Let's say that is how it's according me going to go. We start with these systems, with battery hybrid systems, and then we move more and more to batteries as the battery density is increasing. But for hydrogen, I really don't see this happening because then you have to have dual fuel systems on board. You have have to have the jet fuel on board, but also a lot of hydrogen on board. And in a fuel cell, that makes it already difficult, because in a fuel cell, you are converting hydrogen in electricity, but you can't use it for burning jet fuel or something. So that is, to me, it's difficult to see that hybrid systems in hydrogen are really going to play a role.
Yeah.
Hybrid systems are going to play a role in battery electric aircraft because that's pretty easy to make.
From your KLM days, how would hydrogen mess with turnaround times? Can we still keep these tight schedules?
Well, that's the problem because tanking an aircraft with hydrogen is really complicated. For jet fuel is really easy. You put the jet fuel in, and the vapors are coming out of the wingtips where we have vents. But hydrogen tanking, you may not vent it overboard. That is forbidden because it's so explosive. So that means for hydrogen tanking, you actually have to connect two hoses, one to put the liquid hydrogen in and one to put the gaseous hydrogen out, which you have to compress then again to make it liquid, etc., etc. So that is already a more complicated process. Then you, of course, you have to have far more hydrogen in volume than you have jet fuel, so the times are going to be bigger, the refueling times, or you have to make the hose a lot bigger. That's also a possibility. But then you get the problem, and that's especially a problem with long-range aircraft, that the hose is getting so heavy that people can't lift it anymore. So you have to have some kind of automatic docking system, which with a robot assisted docking system, that you can really get enough hydrogen in the aircraft in sufficient time. Otherwise, with the current infrastructure, it will, for short range flights, it will not be that kind of a problem. But for long range flights, it is really an obstacle.
Yeah. So this really paints a picture how much change is needed for something that's not proven. And different flight phases. How does hydrogen change the game there? Say
Um,
takeoff, cruise, landing, what's different?
No, that is not so much different. If you which fuel you are going to use, the problems with hydrogen are more or less in the production of hydrogen and the storage of hydrogen.
Yeah.
But if we manage all that and you're going to fly with hydrogen, then the range and the characteristics of the aircraft in takeoff and landing will not that all be that different.
Yeah.
The only difference is we use, of course, if you are going to use fuel cells, it will be an electric propulsion, but that is all not all that different uh, from a turboprop propeller or these impacts on flight phases. Once we got
Yeah.
the hydrogen in the aircraft and all the technology figured out, that won't be that difficult. That will be there. The only difficulty is that for long-range aircraft, you really have to make a landing in between because you can't take so much hydrogen. You can't, if you want to fill a 787 with the same range with hydrogen, you need around 400 tons of hydrogen, 400 in volume, 400,000 liters of hydrogen. Yeah, so that will be a problem. That's not
Yeah.
going to happen. So that probably, if we fly such a long range route, it will be an in between landing somewhere where we refuel and then fly the next stage. So
Yeah.
that is an operational limit which you're going to have.
So what about ground handling? That's got to be the whole new world. What needs to change there? You
Yeah,
mentioned a little bit about refueling, but also other aspects.
yeah. Well, the first problem with refueling, how do we get these enormous amounts of green hydrogen at an airport? That's the
Yeah.
first thing. So there are a number of possibilities, of course. You can do it by trucks, you can do it by pipeline, or you can make the hydrogen at the airport. That is also a possibility. Well, if you go for trucks, for instance, I did a quick calculation on Frankfurt Airport. If you want to fly all these flights with hydrogen, you need a truck to the airport every 44 seconds. So that is not really a very good solution. So the problem will be that we are going to look for pipelines to the airport. That is a second possibility, but yeah, transporting hydrogen on long distances is not very economical. So the most probable solution will be that we make the hydrogen, that the electrolysis plants will be on the airport.
Mm.
And from there we bring it to the aircraft. That is the most probable solution. But then the question arises: yeah, how much energy do you need? Well, I said already, for the European flights you need 89,000 wind turbines. But yeah, is that really a solution? Well, it will take a long, long time before this amount of green energy is really there. So the other solution is that you can make, for instance, put a nuclear reactor on an airfield and make the hydrogen in that way. That is really suggested. For London Heathrow, it is suggested that you need 2 to 3 small nuclear reactors to produce this hydrogen. Yeah, that will be expensive hydrogen. I can tell you that, very expensive hydrogen. So, but if for an operational standpoint, from an airport view, I think this is a huge challenge. How do we get these amounts of hydrogen to the airport?
Yeah.
That is, yeah. I don't see it happening soon.
We talked about flight dynamics. What about weather conditions? Do hydrogen planes handle them differently? What's the deal there?
No,
Is there any impact? No.
no, there's not much impact on that one. The only thing what bothers me a little bit is that if you have those cryogenic tanks on an aircraft, they have to be well isolated so that the fuselage doesn't get cold. Otherwise, you get all in humid atmospheres. You get already ice on the fuselage due to these cryogenic tanks. But that can be managed. That is,
Mm.
I don't see that really a problem.
And maintenance and inspections, what new headaches are we looking at?
Yeah, that is also a very good point. You don't smell hydrogen. So if it's
Yeah.
going to leak somewhere, you have to have sensors in place to to detect this hydrogen, and they're enormously expensive. So if you have a maintenance in a hangar with a hydrogen aircraft, you will have to have sensors in the hangar to detect if there's hydrogen leaking. Because 40 grams of hydrogen mixed with air, if you light this, it's an explosion equal to a ton of TNT. Sorry,
Mm.
not a ton, a kilogram of TNT. So that is really a problem. As long as the aircraft is outside, yeah, then the hydrogen is evaporating really fast. So that is not that kind of problem. But in enclosed spaces, that is a problem. And it is the same with the aircrafts, the conventional aircrafts that are constructed now. The hydrogen is sitting exactly in the same place as the passengers.
Yeah.
So yeah, so you have to be really sure that this hydrogen can't come in the cabin somehow, because then you have really a potentially dangerous situation. So, and maintenance on hydrogen aircraft is way, way more expensive than, for instance, a battery electric aircraft, because of all the dangers and all the very complicated equipment which is required. So, this maintenance costs with hydrogen aircraft will go up. There is no doubt about it. They will be more expensive.
Yeah. And the new procedures and everything. Yeah.
Yeah, new procedures. Yeah.
And let's look at the emergency procedures. What's different when shit hits the fan with hydrogen versus regular fuel?
Yeah, well, that depends, of course, on the situation. If you have a crash of an aircraft, you have, of course, a potential explosive situation. But the advantage of hydrogen is that it really evaporates really fast. That is the advantage. So it depends on the situation what happens. The very dangerous situation is when hydrogen gets into places where it can't escape. That is that is dangerous. That is the really dangerous situation. Yeah, so and if you have a hydrogen leak on board the aircraft, you can mitigate this by making sure that it goes outside fast. And so that is really vented into the atmosphere really, really fast. And then the hydrogen explosive chance is not that big. But as I said before, the big drawback is that it is somewhere sticking around in enclosed spaces. And then you have a potential really dangerous situation.
Yeah. That's very interesting from that aspect of security. And what about pilot training? How do we need to update that? Is there anything that needs to be done? What new skills are we talking about?
Well, we have to, of course, develop procedures for instance, what happens if you have a hydrogen tank on board which is leaking. We have also procedures for fuel tanks when they're leaking. There are procedures for it in the aircraft, and they will obviously change. There's
Mm,
no doubt about it. But that is more a procedural thing than it is a technical thing. Yeah, pilots have to be trained that they have a potential very explosive fuel on board an aircraft, and all the dangers that come with it. So you have to really make procedures for that it is really getting safe.
yeah. Uh, weight and balance. That stuff's crucial. How does hydrogen change those calculations?
Well, of course, hydrogen is much lighter than jet fuel, but you need more of it. So that means for the weight of the balance, it is really a design issue. If you can manage the center of gravity of an aircraft between those limits, and you can do that, for instance, by placing some of the hydrogen in front of the cabin, in front of the aircraft, and some tanks at the back. But that is manageable. That is not impossible to
Mm,
mitigate those problems. That is that for the center of gravity calculations. That will mean that you see now lots of aircraft with the tanks only at the back of the aircraft. Well, yeah, then of course the center of gravity will move to the front because hydrogen is lighter. But the rest of the equipment of hydrogen, like fuel cells and batteries, what you need is considerably heavier. So, but that is from if you start from the beginning and make this correct, then it is manageable. That is no problem.
yeah. And what about the regulatory standards? What new rules do we have, to develop, and what do we need here? How to keep this safe
Well,
worldwide?
yeah, well, you have to prove to the authorities that you have managed this safely. That the risk of explosion and other leakage and whatever you can come up with, what kind of failure, that it is managed in procedures and that there are not any hazardous conditions arising from this. That you have to prove. So that is up to the aircraft manufacturer. He has to prove that all these things can be done safely, that you can safely manage in an emergency like leakage or any other thing, that it is possible.
Yeah.
So yeah, that's a bit complicated, but if you have a chance of something happening which is 1 to 10 to the min minus 9, there you have to make procedures for. That's just as simple as that. So if you expect a hydrogen leakage in a certain amount of time, then you have to make procedures for it, and you have to make the aircraft design so that it is safely mitigated, and the pilots know what they have to do, have to base a procedure to get the aircraft back on the ground safely. But that's all there is to it. So that is really up to the manufacturer to make these procedures and put them in the quick reference handbook of the aircraft.
So we talked about new designs, but what about converting existing aircrafts, like versus new design? What's smarter to play here?
Yeah, well, the really problem with existing designs is that the hydrogen tanks has to be put in the passenger compartment.
Yeah,
So yeah, it will cost you payload. There's with existing designs. That is the drawback here. It's going to cost you payload. And with new designs like blended wing bodies, you have far more space to put the hydrogen in. And that is really the advantage you have. But yeah, I think you have to do this because even if we're not using these blended wing bodies for hydrogen, they still have an advantage of 12 to 15% fuel saving in conventional aircraft. So there is really no reason in my port, except of course that designing a whole new aircraft is going to cost you a lot of money and it's difficult. But there is really no drawback to switch to those for long range route to switch those to those blended wing body designs. I would, if I was Airbus, I would start with that design to make hydrogen. And if
yeah,
hydrogen fails, you can still use it as a conventional aircraft, and it saves you also 13% of fuel. So why not?
yeah. That's very wise.
Yeah.
We haven't spoken about cargo operations. What special challenges do we face there with hydrogen? Is it still again the space or some other things?
Yeah, it's pure the space.
Yeah,
That is also with cargo aircraft. It's not different from passenger aircraft. You can also uh, take 40% less cargo on a long range route as to 40% less passengers.
yeah,
It's the space to transport cargoes from A to B is just smaller if
yeah.
you use a conventional aircraft. Yeah.
So talk about network planning. And you mentioned that if it's a long range flight, it needs to land, refill, and continue. So how would hydrogen change airline route structures?
Well, not so much, of course. But the only thing is that you put in an intermediate stop. But the routing of hydrogen, of course, you have to yeah look somewhere for in your route planning for an alternate airports where you can land and refuel the aircraft. And that is another probably problem which is with these hydrogen planes. You may have installed hydrogen on Amsterdam or Heathrow or Frankfurt, but you have to make a planning to go to another airport and also alternate airports. And do
Yeah.
they have hydrogen? Because if you're diverting to an airport where there's no hydrogen, yeah, then you're stuck for quite some time there. Eh?
Yeah, yeah. And assuming that they have hydrogen and that everything is a fairy tale, you still have additional costs of
Yeah,
landing there. You have additional landing for passengers who need to sit in the airplane or go outside and do something while this is happening. And this will not happen in quite like a few minutes. It will potentially happen in 1 or 2 hours, you know.
yeah,
So
and
that is,
I think the regulatory authorities are not going to allow to fill a hydrogen plane with passengers on board. I think they all have to leave the aircraft. Yeah,
wow.
that's pretty sure because that is dangerous. Eh?
Yeah. So basically, we're talking about a lot of hassle and a lot of more costs for
Yeah,
this.
yeah, potentially a lot of more costs. Yeah, they have
Yeah.
more maintenance. You have less payload. You have a very expensive fuel. So it's going to cost a lot more.
So bottom line, we know what's happening around with some companies that just went bankrupt. There are still some companies who are trying, and they're not really in the news these days. But is hydrogen aviation actually going to happen? Are or are we chasing the pipe dream? Like, what do you think about it?
Well, I think we're chasing a pipe dream, because it's tried before, and that was also not. People came to the conclusion that that is just way too complicated and too expensive.
Yeah.
And I think that once we figure out, and you see it now already a bit in the other hydrogen fields, the hydrogen hype is a bit coming down on the moment. You see all kinds of projects when people see the real costs. Oh, and then they say, "Oh no, it's not
Yeah.
going to happen." And I'm a bit afraid that the same thing is going to happen to aviation. Once the companies know how unbelievable expensive, how difficult the operations and the maintenance are, they say, well, oh no, we're not going to do this.
But did they really had to try it in order to discover that? Shouldn't they just, know that in front or being better informed?
Yeah, I think there is a lot of yeah, subsidies going around, of course. That is,
Oh, that's
yeah,
the reason.
that's one of the reasons, yeah. And yeah, and people tend to learn not much from the past, that this is tried before. To start a hydrogen economy has been tried already since the first oil crisis in 1973, and
Yeah.
we had the same hype then from, oh, we're going to put hydrogen in cars and this and that, and yeah, it didn't happen. And
Yeah.
the reason that it didn't happen was it just is too expensive.
Yeah. It's clear. So, what do you think is the future of clean aviation? I want to mention that I've read the other day that Rolls-Royce stopped working on electric motor or electric airplane. So that was a big one.
Yeah.
And what do you think, would be the right path?
Well, I think the right path is that we go from the bottom up. So we start with the short regional aircraft because battery density has now reached a level which those routes can be done with electric aircraft only. So not a hybrid anymore, but electric aircraft. So and battery density is increasing. That is not increasing. It was increasing about 8% per year in the past, but now it's really picking up. And so I think the routes and the number of passengers you can fly with these aircraft is gradually increasing, and they will take up a much more share as each decade goes by. So that is, I think, what's going to happen. And where it exactly ends up, yeah, I'm not a battery expert, I must admit. So, but my projection is that battery aircraft will fly around 1,000, 1,500 kilometers range in the future. And then we're stuck with the rest. Well, what's happening with the rest? I don't think hydrogen is going to play a role there because it's simple too expensive. So the rest of the aviation, the long range routes, will probably switch to biofuels. That is my projection. So I think around 1,500 kilometers will be battery electric aircraft, and above that we simply switch to biofuels. And there are a lot of people saying, oh, there are not enough biofuels. But remember that we put a lot of biofuels in cars these days already. And that can all switch to aviation, because for cars, it is already decided they will be battery electric in the future. That is almost sure. So we can transfer these biofuels to aviation. And I did a quick calculation of this. And if you look up that everything about 1,500 kilometers go to battery electric, then there is enough biofuel for the rest of aviation beyond 1,500 kilometers.
Bernard, thank you so much for being my guest today. I think everybody's clear now with whether they're going to fly with hydrogen airplanes.
Yeah.
Thank you.
Yeah. Okay, you're welcome.
Looking to amplify your brand in the hydrogen energy sector? Welcome to H2 Energy News, your go-to platform for impactful industry insights. Every month, we connect with over 80,000 visitors and generate more than 251,000 page views. Our reach is unmatched, with over 1.2 million web impressions and a loyal social media following of 9,000 plus. Our newsletter reaches 77,000 plus subscribers, decision makers, industry leaders, and innovators. Want to target specific markets? Our geo-targeting capabilities cover Europe, the United States, and the MENA region. We reach key stakeholders, 27% senior executives, 32% directors, and 20% owners and partners. H2. Energy News isn't just a news platform, it's where the hydrogen energy community converges to shape the future. Join us and let's make an impact together. Visit energynews.biz and take your brand to the next level.